Now for part C of the lab, it's the summing amplifier. And as we explained in the introduction slides, that in the pre-lab you used 3 sources of the function generator, 3 voltage sources, but in the lab at each station we only have 1 function generator. So we used 3 resistors in series to generate 3 voltages from 1 function generator. So V input here, this is the input from the function generator, and it's 10 volts peak to peak, which is equal to 5 volts magnitude, and we connect 56 ohms in series with 33 ohms and 22 ohms. So from this point we get 10 peak to peak, from this point we get 5 peak to peak, from this point we get 2 peak to peak. Then we are using 100 kilo ohms for all the input resistors and the feedback resistor. So this is the summing inverting amplifier. So the input goes to the inverting input, which is pin number 2. Pin number 3 is connected to the ground, and the output is for pin number 6. So now for the circuit, here's the amplifier. So from the left is pin number 1. We're not using pin number 1 and pin number 5 and pin number 8. So let's start with the voltage divider circuit, the 56 in series with the 33 in series with the 22. So this is the 56. In series with the 33. In series with the 22. Then to the ground. Now the input from the function generator, this goes to the ground, and this is the signal, goes to the 56 resistor, 56 ohm. This goes to the ground. And again we're using the blue rail to connect the ground, the red rail to connect the positive voltage, the upper blue rail to connect the negative voltage. And then from this side we connect the 100 kilo ohms. Use this wire, and here's 100 kilo ohms, and then from this point to another 100 kilo ohms, then from this point to another 100 kilo ohms. So now all the input 100 kilo ohms are connected to the same point. Then from this point we need a wire to pin number 2. Here's a wire from this point to pin number 2. Pin number 3 is connected to the ground. pin number 4 to the positive to the negative V, and pin number 7 to positive V. Here's pin number 4. To the negative V. Number 7 to positive V. And there is a feedback resistor, 100 kilo ohms, from pin number 2 to pin number 6. Here's the feedback resistor. Pin number 2. Now pin number 6 is the output, and this output is connected to the probe on channel 2 from the oscilloscope. So this is the probe that's connected to channel 2 on the oscilloscope. This goes to the ground. This goes to the output of the amplifier, which is pin number 6. The second step is to apply power to your circuit and then apply signal from the function generator. So the same settings on the DC power supply, the same as we did in part B and part A. So apply power and then apply signal. The next step says to set the function generator frequency between 1 and 10 kilohertz. So I'll choose 1 kilohertz, and then press the oscilloscope auto scale to display the waveform. And then set the function generator amplitude to an amplitude just above the to set the function generator amplitude to a value that gives the peak to peak one equals 10 on the oscilloscope. So here's the amplitude, 10, peak to peak, auto scale again. So we notice here that peak to peak one is not 10. So we need to increase the amplitude here until it's exactly 10 on the oscilloscope. So now it's exactly 10 on the oscilloscope. I'll press auto scale again. The next step says center channel to waveform and maximize. So this is just press on this knob to center channel 2, then maximize it. Then measure on the oscilloscope each of the 3 voltage outputs from the voltage divider circuit. So on the oscilloscope and using the probe, we want to measure the 3 voltages at these 3 points. So we want to measure the voltage at this point, the voltage at this point, the voltage at this point. So let's just start with the first one, the voltage. So this is the probe. This goes to the ground, and this goes to the first point we want to measure the voltage at. So the probe is connected to channel 2, and peak to peak 2 is 10, and this is exactly what we want. So we want the voltage from this point to be 10 peak to peak. Now let's measure it at this point. At the second point, which is between between the 56 ohms and the 33 ohm. And notice peak to peak 2. Peak to peak 2 gives 5 volts, and it's exactly what we want. So at this point between the 56 ohms and the 33 ohms, peak to peak 2 gives 5 volts peak to peak. Now let's measure at this point. So peak to peak 2 on the oscilloscope gives 2 volts, and it's exactly what we want. Now the next step says measure on the oscilloscope the output of your summing amplifier. So the output of the summing amplifier is at pin number 6. So connect the probe to pin number 6 on the op-amp. So this is the probe, and here's pin 6. Notice peak to peak 2 on the oscilloscope. So peak to peak 2 is 16.7. Then you need to calculate the gain, and the gain is the output, which is the peak to peak 2 divided by the sum of the inputs, which are the 10 volts plus the 5 volts plus the 2 volts. So it's 16.7 divided by 10 plus 5 plus 2. Then you need to capture this waveform. So save this waveform, and then press to save. And then to find, now we want to find the cutoff frequency for the summing amplifier. So this is the frequency response of the summing amplifier. We want the maximum voltage, which is peak to peak 2, 16.7, and then we need to divide the maximum voltage by root 2. 16.7 divided by root 2 gives 11.8. Now, so this max is at 1K, and 1K is here. Now we want to increase the frequency until peak to peak 2 equals 11.7. So go to the frequency here. Frequency is at 1K. I need to increase the frequency, and notice peak to peak 2 until peak to peak 2 is 11.8. Now peak to peak 2 is 11.8 at this point. So the cutoff frequency is 25 kilohertz. Now the last step, once we're done, we need to remove the signal from the amplifier. So turn the function generator off, and then we need to remove the power from the amplifier. So we need to turn the DC power supply off. So turn channel 1 off, and then turn channel 2 off.